Hi, my name is Alan On, Director of Programs and Communications for the Global America Business Institute, or GABI. You're listening to a nuclear energy podcast hosted by GABI. First of all, hope everyone is safe and healthy during this time. Today's podcast interview is with Rob Sweeney. He is the President and CEO of IBEX, a professional services firm that has been involved with major energy and infrastructure projects with a special focus on nuclear power. Rob, let's just dive right in. Could you talk a bit more about your company, IBEX, and more generally about your career in the nuclear field?
Sure, Alan. And first, I want to hope that everybody is well and keeping safe during this unfortunate time, whether here in the U.S. or elsewhere around the world. Secondly, I want to thank you, Alan, and Gabby, and Florence for having me here today and this opportunity to engage with you and your Gabby community. To answer your question, well, I came into the nuclear business after TMI, an interesting time to say the least. I worked for Ebasco Services. At that time, it was a global leading engineering and construction company, which is now part of the AECOM company. It's a legacy company to AECOM. I started out in the company in its New York City headquarters at Two World Trade Center, performing project engineering support, and I also had several construction site assignments. I was later selected to go to Washington, and that's what brought me here eventually, as a seconded FPL manager in charge of leading efforts to secure the operating license for St. Lucie 2. I have to say that was quite the blitz effort then. We managed to license it in just a few years. That's an operating license in just a few years. However, got to say the project team was first class, dedicated all around, and I have to say definitely is a model project that also set up post-TMI benchmark for licensing and construction. Well, after that, I went back to New York City. No sooner did I land at LaGuardia, I was asked to go to New Hampshire and to join a turnaround team at the Seabrook project as part of the executive team's 5-member independent review team. And that led me back to Washington, D.C., ultimately, running the project affairs and securing the operating license with the NRC, which we did. That's more time than we have for this webinar to go through all the details and trials and tribulations with that project. However, it was successful. I never thought it would take us 2 years to finish construction, but we did. And however, it nearly took more than 4 years in litigation and political battles. I think that our situation really helped focus our industry on the cost of needless intrusion and abuse of the regulatory process, and hope that that never gets repeated again. Well, from there, I started up Ebasco's presence in DC, supporting a number of corporate divisions and key commercial and government clients. And I also met my bride, my wonderful wife, Roxanne. So I ended up staying in Washington after that. At that time, I knew I was going to be here for a while. And from there, I was recruited to a boutique consulting shop. And then several years later, I decided to start up IBEX in the mid-90s with a couple of industry colleagues, Bill Derrickson being one, and some Wall Street guys. We developed IBEX businesses, actually, to support energy and non-energy projects, including airports, development roles on a number of different types of projects, tar sands, ethanol, refinery projects, interesting stories behind them as well. With respect to IBEX, we've been involved in a lot of different things over the years, including combined cycle, T&D upgrade projects, yet much of the core has been supporting commercial nuclear projects and companies in and around the industry, from inspections, oversight, analysis of plant assets to new large build and small SMR applications, doing technical and licensing work, as well as digital upgrades and power upgrades, to name a few. We've also been involved in back-end services, including some decommissioning support, spent fuel management technology, licensing and project support, as well as supporting Yucca Mountain. Well, I must say, over the years, we've had the honor and pleasure to work with some of the world's leading EPCs, equipment manufacturers, utilities, special services companies, to say the least, as well as the Department of Energy. So that's not quite A to Z, but it has been interesting.
As part of your commercial nuclear work at IBEX, you worked with KHNP, Korea Hydro Nuclear Power, on their APR 1400 license application to the NRC, which by all accounts was a tremendous success in how quickly and smoothly it proceeded. What were some of the things that KHNP did to streamline the process as much as possible?
Well, that's a very good question. But before I answer that, let me first start off that, as with any project, there will always be bumps in the road, as well as unforeseen events that bring challenges, as well as potential risks. The good thing is that KHNP and the APR 1400 project team took them head on, I must say. KHNP overcame many challenges and used them to their advantage to meet 42-month schedule. So I have to say that if there was a challenge, there were plenty of hands on deck to answer the call. And in any event, to answer your specific question, as Albert Einstein once said, we can't solve problems by using the same thinking we used when we created them. So that said, I think KHNP instinctively manages their nuclear design and construction programs consistent with Einstein's viewpoint. One thing that I've learned about Korean culture, in fact, is I recently heard it just the other day in the context of the approach that Korea has taken with respect to coronavirus. Korea's culture seeks efficiency, an inherent desire to meet things head on, I guess. And part of that culture is taken from lessons learned. And I know KHNP is very big on lessons learned. So as for streamlining, well, there are some examples both that the APR 1400 project did in Korea as well as here in the United States. But let me just talk about a few of them. First, as you know, KHNP led the project team's effort to secure the license certification and standard design approval. However, there's never a question, I guess, as to who was in charge and their commitment and their expectation that everyone had their job to do and to do their best. And to help things along, KHNP established a dedicated team of over a dozen technical and licensing experts in Washington, D.C., putting decision makers at the doorstep of the NRC. Effectively, the project team was a shadow project management team in the U.S., and this allowed for the necessary technical and managerial response and the vital interactions that were necessary to support the staff review and project management. I think this went a long way to making sure that there was continuity, and there's other examples as well. There was, with regard to overseas, being 13, 14 hours, depending on the time of year, it was difficult sometimes to deal with that, but eventually I think the project came out where one takes these normally perceived unfavorable time differences, and we took it to our advantage, essentially working the project around the clock, in effect, mimicking production of back-to-back 12-hour shifts, essentially. So I think we initially took the situation as an unfavorable situation and put it to our advantage and made it more efficient. And so we worked closely with the NRC to help drive other things. And one particular area was information technology and associated administrative tools to help manage the exchange of information, the interactions, et cetera. And with the assistance of the NRC project management team, We utilized the agency's electronic RAI system, for instance, beyond simply just checking off the box and did the RAIs get completed or not. And so we use the system to provide critical data and metrics for project management purposes for both NRC and KHMP. We used it very effectively and held weekly and biweekly meetings, and very effective when it came to managing the numbers. KHMP was also the first certification applicant to exclusively submit licensing documents to the NRC via the electronic information exchange system. I think the subsequent applications are taking that road as well. This really resulted in real-time transmittals, cost-effective configuration management. We didn't lose things, and I think it was to the benefit of KHMP and the NRC as well. We also streamlined the use of audits and deployed electronic viewing information platforms, several of them, and that also helped reduce and streamline the ability to look at information and unravel unnecessary burdens for both the NRC and KHMP. We highlighted a number of other things we did in a paper we wrote last year, and that was published by Power Magazine in July of 2019. So there's a litany of things, both on the licensing fronts where we were innovative, as well as on the design side. And if you go to their website, you can pull it up. It's entitled "Bringing the APR 1400 Reactor to Market," and the website is powermag.com.
You may have hinted at some of these already, but on the topic of lessons learned, were there any lessons from the APR 1400 experience at the NRC that might be applicable to SMR and advanced reactor applicants, as some of these companies like NuScale and Oklo navigate or begin to navigate the NRC licensing process?
Well, yeah. Well, first, navigating the NRC licensing process is not and should not be a complicated thing to do, and shouldn't be a hindrance or a burden to anybody. There's hundreds of applicants that have traveled this path before and successfully. Success is really about planning your mission and being prepared for whatever weather forecast before you embark on the venture. So that said, I can tell you that NuScale is benefiting from some of the things that I just mentioned above, as they should, and I'm sure they're doing innovative things on their own behalf that are things that hadn't quite been used before, which is good. And I also see on the Oklo side, since you mentioned them, that they've conducted a lot of important pre-application engagements with the staff. I think those should be important things to help not only them, but others. And those will support them as the NRC goes through the acceptance review and their recent application on their micro reactor. Also, I think the NRC staff commission and the ACRS also learned a lot from the APR 1400 experience. To the agency's credit, they have developed their own internal lessons learned for going forward, and they're using some of that today to help streamline their processes, not only for the current applications going through, but also for the upcoming applications and regulatory process for the advanced reactors. Also, for example, in NuScale's case, they were able to reduce the number of meetings with the ACRS. A lot of unnecessarily duplication of meetings and information exchanges, which basically reserved ACRS review time for issues that were more critical for the safety review, which is a good thing. It allows them to keep on schedule. This is important because when it comes to schedule, ACRS tends to be involved in the later part of the process, and it's not good to have new issues encroach your technical review, safety reviews towards the end of any review cycle. So I suspect the APR 1400 lessons learned in those applications to follow will evolve to be more helpful for the next generation. And as I said earlier, fully expect that the new reactors that will be licensed will be the benefit of some of the things that APR 1400 and the other applicants have experienced. So for any current future applicant, I would caution that if they have anything that's being introduced to the NRC review that's unique or novel, that those elements be addressed early and upfront, especially if they're critical to the underlying safety case, ability to meet the specific criteria, or there's an imperative to maintaining a project timeline or expectation. And also the same holds for should something new come up during the ongoing application review. These are things that really need to be taken into consideration. I guess to sum up and answer your question fully, I would just leave it as a famous philosopher or travel agent once said, seek the counsel and expertise of those who have been there before you.
Rob, you mentioned earlier that KHNP leveraged a global team of companies, consultants on its APR 1400 license application at the NRC, not only involving the relevant entities in Korea, but also a number of US-based engineering, consulting, supply chain partners. How did that work? And was this really necessary for a license application? Could you elaborate a bit on this?
Sure. As I mentioned earlier, KHP established a dedicated project team, but it also brought together dozens of companies and expertise from around the globe. KHP not only relied on the engineering and technology capacity from Korea, but it also relied on numerous U.S. engineering technical specialists and licensing consultants and supply chain partners from the U.S. A few of those include AECOM, Jensen Hughes, MPR, Structural Integrity, and Westinghouse, just to name a few. In fact, KHP utilized a large supply chain to support the certification, but it also relied on dozens of U.S. companies every day, frankly, for supplying its operations and its new builds, including several $1 billion in U.S. supply chain support that came from the U.S. for the units in Baraka in the UAE. I think those collective efforts demonstrate a collaborative international success, something that can be built upon for future cooperation and joint project involvement. As I see global demand for nuclear energy accelerates, maybe not in the U.S., but clearly there are a number of countries that are seeking to expand or develop new programs.
Coopetition, quote unquote, is a word that's often used to describe the state of the global nuclear industry. Yes, U.S. nuclear companies, they face heavy competition from largely state-owned enterprises abroad, but they also partner and collaborate with these entities as well. As you look internationally with the many vendors and firms that form the nuclear supply chain, to what extent is this term appropriate? Where is the line between competition and cooperation?
Well, I must say the neologism has been around a long time. It's not a bad thing, and the concept works. However, it does require that parties think beyond their traditional roles for the greater good of the bigger achievement and outcome. That without the other, there would be no success. And so, and not to mention, where such an arrangement is better suited or required by a project developer or owner, then it is what it is, and firms need to be flexible and open-minded. So a good case to look at is recently with the Apple-Amazon effort to build tracing functionality into their iOS and Android systems to establish a voluntary contact tracing network to help users as well as public officials, et cetera. And that's about obtaining important information and providing infection alerts, et cetera. And that's where this cooperation can work. And it's about the bigger thing and leaving some of the other things aside for the time being, because you're achieving something more and longer lasting. And so that said, the U.S. power generation business has long lived with this kind of situation. Anyhow, for example, not every plant that a reactor or NFIPS vendor can build. They can do both, actually. But on some cases, the NFIPS vendor is not also the supplier of the BOP major components. So that's not uncommon. And so we've seen projects where two EPCs, are working together on one project. One's doing engineering, the other one's doing the construction. It happens. It's been happening for a long time in our industry. And so many times this can be a driver by the customer, driven by the customer, and for a number of operational, financial risk reasons, et cetera. So I think taking each case by case is not a bad thing, and we've always looked at IBEX for partnerships and to work whatever we can work to make a deal happen. So another recent example, maybe the cooperation in Egypt. I mean, GE won contract to deliver turbines, and Rosatom has got a $25 billion project to deliver a nuclear reactor package. So I might be wrong on the number, but in any event, there's cooperation there, and that's international. So at the end of the day, as I noted before, firms just need to be flexible. We need to be open-minded. They also need to be creative, innovative. Not all customers are alike, and not all customers' balance sheets, more importantly, have the appetite to take the financial risks. So firms, teams, JVs, et cetera, they need to be flexible and work to establish the best deal for customer stakeholders and their own firm stakeholders and shareholders. So I guess one should not be afraid of competition. It should embrace it where it's appropriate, and it just may be the future successes internationally by cooperative relationships, because it's really about the longer term relationships and not just the one-offs. And so time will tell.
There's growing dialogue, at least within some circles in Washington, policy discussions, about the need for the U.S. Nuclear industry to partner with its counterparts in allied countries, Canada, France, Korea, the UK. Where do you see the greatest opportunities for cooperation, partnership, supply chain integration among the industries of these countries for both conventional nuclear projects as well as SMRs and advanced nuclear?
Well, first, I think there needs to be more dialogue. While there's been some dialogue, some good cooperation, some joint activities, et cetera, there still appears a lack of constant and consistent dialogue sometimes. And it's just not bilateral. So some may say we need to be developing a new platform for improved dialogue. Okay. Policy coordination, cooperation. Okay. And it just may be there needs to be such a vehicle. We'll see. I think we can build something like that. However, a little investment of time, a tiny portion, in fact, should be invested in developing the right cooperation, the right relationships that can lead to transactions. Ultimately, it needs to lead to transactions. And that is developing the right relationships to go to delivering beyond one or two new reactors. I think if we think fleet and if we think big, it gets really exciting. And I think, be it bilaterally, multilaterally, we can get there. At the end of the day, a strong strategic relationship is key, where mutual goals, of transparency, sharing the risk, and reward are underlying values. They will be key, I think. It needs to work for each party, no matter how big the pie is. Each has to get its rightful share. So we need more cooperation, discussion. We need to understand where we all fit going forward. That said, we can see beyond bilaterals. And I think the more flags in the room, the better when it comes to a deal. In particular, in some regions of the world, it can be very, very helpful. I think we already see this. I can envision more bilateral and multilateral dialogue to secure projects without a doubt. So I also think this could be helpful in the fuel cycle solutions and R&D areas too. I mean, globally, it would be interesting to see more progress on maximizing the value of the current spent nuclear fuel, developing fuels and processes that support future generation, the non-light water technologies, et cetera. Ultimately, working on the back end technologies and solutions for waste reduction, consolidation, ultimate disposition, and residual waste, managing residual waste constituents, they all need to be safely secured and disposed. And that I think can help in an important step in the right direction.
With all the emphasis on meeting clean energy goals, carbon reduction targets in the long term by 2050, both domestically, internationally, how do you envision nuclear's role? Do you envision nuclear will be a big part of that mix to allow these goals to be achieved? And obviously that has relevance to your talk about looking at the market more broadly, a fleet as opposed to just a few reactors here and there.
Yeah, well, that's a very, very good question. There are different views on this within the U.S., regionally and state and federal levels, and internationally as well. But let me step back here to answer this one. First, one needs to validate an assumption out there that the materials, the manufacturing, and the markets are even going to be there to produce and manage the level of clean energy generation that's needed going forward. I got to tell you, I am an all the above energy guy and promote clean energy solutions wherever we can do it. However, to date, I have not seen any definitive study that can substantiate or support we can actually get there, and from a couple different perspectives. But that said, let's assume for the time being that, or let's put in context, 2050 is 30 years away from now. Given the current wind and solar resources, for example, that we have operating today, and those planned to be installed in just the coming years, those facilities will all outlive their design life. So essentially, they all have to be replaced. Meanwhile, a fair portion of our existing nuclear fleet will continue to operate beyond 2050. And newer plants are going to run well into the next century. So the existing wind fleet and solar fleet will not only need to be replaced, there will be a need for several fold of that to even continue on this trajectory. Okay, excluding non-hydro, several fold for the current non-hydro fleet in the U.S. to come close to meeting 2050 goals. So good chunks of our current fleet rely on foreign supplies, including China. So going forward, bulking up on more wind and solar could come at a price as well as risk. So I think these things need to be considered as we all look to 2050. We can talk about capacity factors too. I mean, today we have about 100 gigawatts of nuclear, 100 gigawatts of wind, and getting close to that from solar. However, capacity factors are a third of what nuclear is. So when we talk replacement, we're talking a whole bunch of replacements to even get the equivalent of what we have from a nuclear reactor perspective. The energy density is by far where the value is in nuclear. And I think hopefully over time, studies will show that it has a bigger part and component with meeting future clean energy goals, be it 2030, 2050, or 2100. So there are issues to getting there. A lot of the supply chain in the U.S. Does not have the capacity to do what we need to do going forward, and we rely on a big share of that from foreign entities. So I think we need to look at supply chain issues as well, because this is all strategic. Energy is national security, like it or not. So I think nuclear should see a fair share of the 2050 market. How big that will be, I don't know. But planning for that definitely begins today.
A final question on the current coronavirus outbreak and its effects, and obviously we all personally feel its effects right now. There's clearly been an impact on the global economy, international trade. How might the outbreak increase supply chain risk and negatively affect the international nuclear supply chain, which has been built up over the decades?
Well, good question again. Well, in trade, as I think I've mentioned before, transparency, mutual respect, and trust builds relationships, and it also helps to build business. For supply chains to be effective, there needs to be performance, obviously, quality, price, delivery, etc. Uncertainties and risk are no friends of supply chain professionals or the people behind them that count on them, okay? Or for trade professionals, it's all the same. First, let me just step back a little bit. I have to commend our industry, our U.S. and allied industry partners as well, and the regulators. We have come a long way to making the commercial nuclear power business the most dependable, highest quality, and safety conscious industry in the world. Here in the U.S., the industry and the NRC have gone a long way to become the leaders around the globe when it comes to ensuring quality and integrity of the supply chain, especially in the area of quality control, controlling suspect parts, managing obsolescence issues, and most recently, over the last several years, ensuring cybersecurity through all phases of the procurement process. Just to name a few. We could spend more time on a host of those, and it's just not parts and components in the plants. The U.S. industry, after Fukushima, put into place in the event of an accident, they warehouse backup equipment and materials in an unlikely event of an accident at one of our operating plants in the United States. So there would be no lapse. There would be swift deployment of the necessary supplies and materials to respond. So on top of that, the U.S. nuclear power industry has already planned and looked at provisions for pandemics. So, and we're seeing the benefits of that even today, especially today. So now moving forward, as the coronavirus unfolds and issues unfold as a result of that, there could likely be some recommendations to ensure supply chain risk is addressed at a multitude of levels. Prior to the coronavirus, the global nuclear supply chain were experiencing stress and trade negotiations. The fissures were becoming more and increasingly evident, particularly with China. While it's a little early to tell, I think the current situation will have any number of countries reevaluating their current overseas operations and supply chain partners, and I mean manufacturing operations, likely seeing that other manufacturing locations and partnerships will be elsewhere, and I can envision things moving to India, other regions, Southeast Asia as well. I also expect many countries, including the U.S., bringing back home, redomesticating some portions of its supply chain, especially those manufactured goods critical economic or strategic national importance. So we shall see. But for now, I hope people get well and back to work soon. We'll get through all of it.
All right, Rob. Thanks again for joining us. Really appreciate your time to do this. First and foremost, stay safe and healthy. Thanks again for sharing your insights and expertise today.
Yeah, will do. Thank you so much, and my pleasure today. And be safe and well.
Okay. All right. Thanks so much, Rob.
Bye-bye.